Hello, and welcome to Backer Breaks It Down. Today I want to talk to you about inscribed polygons. So in our previous lesson, we talked about inscribed angles. So I'll just go back to that. And an inscribed angle is an angle whose vertex is on the circle. Okay, we discovered that when it comes to inscribed angles, the measure of an angle is equal to half the measure of its intercepted arc. Okay, so now I want to apply that idea to polygons. And the first polygon is the right triangle. And so this one kind of follows directly from the inscribed angle theorem. Okay, because if you simply look at that diagram over there, the inscribed angle B, like if I extend the sides of that angle, I notice that the endpoints of that angle are A and C, and AC is a semicircle because the segment AD is a diameter. So the measure of the angle is half the arc. So the arc would be 180, which means that the angle would be 90 degrees. So it makes perfect sense that the angle inscribed in a semicircle is a right triangle. Yeah. Okay. So there's another polygon. It's called a cyclic quadrilateral. And for the quadrilateral to be cyclic, all four vertices have to be touching the circle. So all of the four angles are inscribed angles. Okay. Now the inscribed quadrilateral theorem says if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So that means they add to be 180 degrees. So let's apply these two theorems, okay? So in problems 3 and 4, we're going to apply the right triangle theorem. So use the inscribed right triangle theorem to find the measure of the indicated arc, okay? And so how I'm going to use this is that I see that angle K is an angle inscribed in this semicircle because JL is the diameter. So I know that angle K is a right angle. I also know that angle L is 35 degrees. So if I do some subtraction, if I go 180 minus 90 minus 35, then I'm going to get that angle J is 55 degrees. So when it comes to arc KL, remember I know the angle, so angle J is half of the arc, so arc KL. I can also use the alternate formula that 2 times the angle is equal to the arc. So I think that's the one that I like for this one because I know what the angle is. So if I go 2 times the angle, I get 110 degrees. And that's the measure of that arc that they asked me to find. In problem 4, I'm going to use the inscribed right triangle theorem to find the value of x. So I know that angle R is a right angle, which means that these other two angles have to add up to be 90 degrees. So there's my equation there. So now I'm just going to do some algebra. I'm going to have 4x plus, what is that? 34 equals 90. And then I'm just going about using my awesome algebra skills, or, not. And I'm getting that x is equal to 14. Love this pen. Okay. So if you have an angle inscribed in a semicircle, it's a right angle. And then we can use our other knowledge of triangles to find missing measurements. So the inscribed quadrilateral theorem, remember opposite angles are supplementary. So in number 5, ultimately I want to find angle Y. But I don't know angle W. If I knew what angle W was, then I can just use that whole supplementary thing. So I think I want to try and figure out what is angle W. Because if I know angle W, I can go 180 minus it to get angle Y. So let me take a look at what I've got here. They gave me angle X. Okay, and so I can kind of do like two things with that. Like this angle X is creating the arc WDY. So I can use the fact that the angle is half the arc, or, the arc would be 2 times that angle. That might work better. So if I go 2 times 91, I get 182. And 182 is the measure of that major arc of WDY. So let me just write that down. So if the major arc is 182, that would mean that this little one, dy, I'm going to go 182 minus 80, so that would be 102. Okay, so I'm knowing a little bit more about this circle. Now remember, we said, like, if I know the measure of angle W, I can find the measure of angle Y. So if I extend the sides of angle W, I notice that they're making this arc DYX. And I know exactly the measure of DYX because it's made up of this 102-degree angle and this 84-degree angle. So the measure of arc DYX is 102 plus 84, and that would be 186. So that means angle W is half of that, right? Because the angle is half of the arc. So that makes angle W 93 degrees. And if angle W is 93 degrees, I can now find angle Y because, well, they add up to be 180. So if I go like 93 plus question mark, I'm going to get 180. So that's going to make angle Y, what is that, 87 degrees? Sorry, my pen doesn't like to work over there. And that's my final answer. So like this problem kind of had some like multiple steps in it. But like honestly, if you're like at a loss to how to directly get to like what they're asking you to find, just start finding measurements. Like angle X is 91. What does that mean? That means the measure of arc WDY is 182. What can I do with that? Like just start finding measurements using the information that you're given. And eventually you'll come across information that's going to help you find exactly what you're trying to find. Okay. And it might take you a few steps to get there. Like this one did not have a direct, like, this is how you're going to find Y. It wasn't ever going to be a one-step problem. So honestly, just start finding measures, write them down. Like eventually you'll get the measure of angle Y. Okay. See, I did this one. It looks a little bit differently. It looks like far less work, right? Because there's different ways. All right. Number 6, use the inscribed quadrilateral theorem to set up and solve a system of equations to find the values of x and y. So using the inscribed quad theorem, opposite angles are supplementary. So that means angle L and angle A are going to be supplementary. So that I would just write down 5x plus 11y minus 5 equals 180. And honestly, since you're going to be solving a system of equations, I would write both of these in standard form. So by standard form, look at the very bottom. I mean, ax plus by equals c. Because like one of the methods of solving systems is elimination. And elimination, like you want them both to be in standard form before you go about eliminating anything. So I'm just going to add 5 to both sides to get like the nice standard form equation here. So one of my equations is 5x plus 11y equals 185. So now I'm going to find my other equation. So opposite angles are supplementary. So those two are going to add up to be 180. So I got 7y plus 13 plus 22 plus 5x equals 180. And just like before, I would get this in standard form. So standard form, we will keep 5x and 7y on the left-hand side. And I'm going to subtract the 13 and the 22 from 180. And so that's going to end up, I'm going to end up with 145. Okay, so this is my system of equations. All right. Now I'm going to so are we good here? Because I'm going to erase one of my pieces of work. I'm going to erase this stuff right here because I want us to just focus on the two equations, okay, that are written in standard form. So you can solve a system of equations using the process of elimination. And elimination makes sense when both equations are written in standard form. That's why, like I said, we should just automatically write these in standard form, okay? And the way elimination works is I want to add these two equations together and have something eliminate. And if addition doesn't work, then I'm going to try subtraction. And if subtraction doesn't work, then I'm going to multiply to make addition work. So in this problem here, addition doesn't work. Addition won't eliminate anything. So what I'm going to do is I'm going to actually subtract these two equations. So I'm going to go 5x minus 5x, 11y minus 7y, and 185 minus 145. When I go 5x minus 5x, they completely cancel out. 11y minus 7y is 4y. 185 minus 145 is 40. So what I know is that y is equal to 10, which means it's now much easier for me to find out what x is. I just have to plug this into one of my equations. So maybe I go back up to this one for no particular reason. And so I plug in y is 10. And I get 5x plus 11 times 10 is 185. And then I just solve this for x, because that's what I don't know, and that's what I need to know. And the algebra will tell me exactly what x is. So I end up with, let's see, minus 110 would be 75. And so, no, minus 110 would be 65. Sorry about that. So that means x is equal to 13. And so that's how we can use the system of equations in such a problem, okay? So the bottom line is, if an angle is inscribed in a semicircle, it's a right angle. If you have a cyclic quadrilateral, opposite angles are supplementary. And that's how Backer breaks it down.